Alright, just let me make sure that this is on. Alright, let me see here. Okay, I think we're good. Alright. Well, good morning, good afternoon, and good evening, wherever it is that you are tuning in from. Thanks for joining me again for another round of these live streams. Today we're gonna keep talking about uh, basically using NumSharp and these different libraries and tools available like .NET Interactive to perform data analysis. And we want to be doing that all in .NET, right? So let me kind of pull up a few things here while in the meantime. And I hope that you folks had a chance to attend the virtual ML.NET, the first iteration of it. I may be biased in saying that it actually was very successful, and everything came out as planned. So yeah, I mean, it was fun. It was a lot of fun getting all the questions, interacting with the community, seeing all the really amazing presentations that the presenters had put together and the different projects that they had been able to build. I'm certainly inspired, and I hope that the community was inspired by those talks to go out there and at the very least try it out, right? See how they can uh, start adding machine learning into their day-to-day work, um, or seeing ways how they can essentially explore data and try to identify trends in the data sets that they already have, and hopefully take some of the ideas that were talked about on Friday and Saturday and just start applying them. Let's see here. Okay, so while that's loading, and let me look for the actual workshops. So it'll be GitHub, um, reactors. So again, what we're doing here in this stream is we are taking a look at these reactor workshops. And again, Microsoft reactors, they are these hubs, different offices that where Microsoft provides a space for entrepreneurs and community meetups, all types of groups to sort of come together and for them to have a space to collaborate, to interact, and to learn, right? And as one of the things or one of the initiatives that these reactors have are these full day workshops that pertain to different topics. Now, the one that we are going through today specifically is this one's called Full Day Data Science, the first day of full day data science workshop. And what this is doing now is it's going through the different tooling, getting individuals familiar with Python, NumPy. In our case, we're using NumSharp, pandas, talking about manipulating data, and there's a project at the end which combines all of the skills or pushes attendees to put into practice all of the skills that are mentioned here. So what we're doing now is we're exploring NumSharp, right, which is the C sharp equivalent of NumPy. It's the C sharp implementation or the .NET implementation of NumPy. And what we're doing throughout all these streams is we are trying to implement most, if not all, of these notebooks in .NET, specifically using F sharp. And you may ask yourself why F sharp, and that is just because I strongly believe that the it is a language as compared to C sharp. C sharp has a lot of really neat features, especially with C sharp 9. I'm really looking forward to stronger scripting capabilities. But for the time being, I do strongly believe that F sharp is the language for these workflows, data analytics workflows. So before we get into that, though, let's kind of walk through the F sharp weekly, try to see what's been going on in the F sharp world. There's the video from our stream that we did last week. There's a few videos on DevOps and ASP.NET Core, computing complexity. Interesting. This one might be related. Okay. Interesting. Mono CSON. What is this? Over a bunch of assemblies, switch codes. Do the job. Okay. So really long. Interesting. It looks like they're using. Oh, they're using scripting. Okay. All right. Interesting. Mutable data structures, conference, what's new, C sharp, Fable and .NET integration, MAUI. Let's see, F sharp command line, Felice, Databot, Twitterbot, output graphs. Okay. Giraffe. What's this one here? F sharp bot, Databot. Okay. Indicators. Oh, and it's for Twitter, I think. Yeah, it looks like it's for Twitter. Oh, it's very cool. Yeah, F sharp on Twitter. Response from I just sent it a message in the format, countries, indicator, start, and year. Oh, this is very cool. Very nice. So these are the types of applications or the type of things we like to eventually do once we get a little bit more comfortable with the tooling and the things that are available to us. Okay, so with that, let me just go ahead and try to go ahead and start Jupyter Notebooks, right? And to do that, right, so we're just here in this folder. So let's start Jupyter Notebook. And again, so we're using Jupyter Notebook to do our scripting and to do our work here. And what Jupyter, one of the nice things about Jupyter is it provides support for various languages, and some of those languages are .NET languages, right? So you have a kernel, which is the one that interprets the code for you with Jupyter Notebooks, and you have .NET Interactive, which is the .NET kernel, and PowerShell as well for Jupyter Notebooks. And what that allows you to do is it allows you to run C sharp, F sharp, and PowerShell code inside of Jupyter Notebooks in this interactive environment. Okay, so we left off at NumSharp last time. And let me kind of put it side by side. Here we have that. Now we want to take a look at this one here. NumPy. Okay, so the one on the left hand side is a Python implementation that we are using as reference, and on the right hand side is what we've been doing so far with F sharp. And I see that we are at the stage where we are imputing values. Okay, let's see, it's taking a little bit here. It's odd. Okay, give it some time. So, did you folks in the chat, were you able to attend the the conference this weekend? If so, what were your thoughts on it? Let's see. Doesn't seem to want to. Oh, there we go. Nice. Okay, so we were past this. We were past indexing, string arrays. Okay, so we're at the create a NumPy, working on NumPy arrays to basics. NP full. Yep, so we were here creating them. Okay. Let's just create an array filled with linear sequence starting at 0, ending at 20. Now, you know, so after taking a look at all these things, right, I'm still not, I mean, I kind of get part of why we would want to use NumPy, right? Part of it is because lists in Python don't necessarily provide you with the ability to, with the rich capabilities that something like NumPy would allow you to perform. But the more that I look at it, a lot of these things you could kind of do out of the box. Um, you could do out of the box with standard lists and arrays in Jupyter. Sorry, in F sharp. So create a file. Okay, so this one, create an array filled with a linear sequence starting from 0, ending at 20. So let's see. Oh, well, first I gotta run this because I still haven't run it. Let me just run everything. Should probably just cell, run send, run all below. Okay. Perfect. Run. I think I gotta upgrade. Okay, so np.a range, and then what it wanted was 0, comma 20, comma 2. Okay. Oh, whoops. 2. Okay, so we can do the same thing, right? 0 to 20 by 2. Built similar to the Python range function, but we could do the same thing with F sharp, right? If we did something like this, right? We did array dot create, and do something like 0 to 20, right? You can see we get the same thing, and if anything, we get it all the way to 20, right? So this makes a little more sense because it's inclusive. We tell exactly where we want to end, and then evenly spaced between 0 and 5. So x np.linspace. So let's see, np.linspace 0, comma 1, comma 5. Okay. Okay. Space start. It's a float 32 stop, float 32 number. Okay. np array type constraint mismatch. Okay. So float 32. So np dot 0 dot 0 0. Okay. It seems odd that in this one I told it here's where I want to start, here's where I want to end. Oh yeah, here's what I want to add, and here's what I want to go by. Okay, yeah, this is very similar. But again, you know, like in that one, that's I had to do that. So here I can just do 0, 1, uh, 1 divided by 5, and then 1. Okay. The step, let's see, step range cannot be 0. Let's see. Oh crap. No, that's not what I was trying to do. One divided by 5. Oh, that's why. So 1 point. Okay. So 1 0 dot 1. Must have type float, but what if I did 0.0 and then this one was 1.0? Boom, there you go. I see what happened. Interesting, but I mean it's very similar in what it's trying to achieve. It's just it depends on. Okay, so this one is np random. Let's see, np dot random, and you want this to be a 3 by 3, right? P.random field constructor. Remember, random is not defined. Maybe you want to define random. Okay. Dot random. Okay, there we go. So it creates a 3 by 3. Okay. And p.random random normal. Okay. Let's see, 0, 1, 0, 1 standard deviation. And for this, we want to have a 3 by 3. Okay. And there's no normal. 0, 1 dimensions. Okay. All right. Fair enough. Create an identity matrix. P.I3. Okay, fair enough. Very similar. And P.empty3. Okay, and P.empty3. 3. Okay. And here we have additional things here. Okay, working with NumPy arrays, the basics. All right. Working with NumPy arrays, the basics. I should probably call it NumSharp. Okay. So in this one, what's going on? Okay, there's 2 here. Let's see now. Array attributes, indexing, slicing, reshaping, joining, and splitting. Okay. So array attributes. One-dimensional, two-dimensional, three-dimensional. Each array has ndim. Number of dimensions of an array, shape. Okay. So, all right. So the attributes. So let's try this. Okay. So boom. So this one, p dot random dot seed 0. Okay. Good enough. Then what we want to do is we want to do this thing, right? Here, 1D, 2D, 3D. Okay, and then we want it to be, instead of size is equal to 6, size is equal to 3 by 4. Okay. Switch these operators around a little because for NumSharp it expects an array, not a tuple. Okay. And then I wonder if this will work. Okay. Let's see. Error. Type cherry. So we're supposed to have type int64, but he has type int. Expression was supposed to have shape, but here it has int. Okay. Or if I get rid of this thing here. Okay. Alright. What is the problem here? Okay, so how do I let's see. F# int to int64. Oh, is that easy? All right. I just don't know which one it wants. It has an int64 though. It wants this. Maybe this one. Okay. This expression was expected to have type int64, where here has type A. Okay. Interesting. Okay. So let's take this one by its own. Let's leave it. Oh crap. Ooh. Can I undo? Undo. No worries. No worries. Let's go ahead and do A1. Let A1 is equal to np.random.randint. And then this one at 110, comma 6, and I'm sure 1D array. All right, and I'm sure that this is gonna complain, and that's okay. Int 64. I think that it's complaining about that second number. This one's int 64. Okay. np.random.randint. So do I get any help here? I don't get help. Okay. All right, let's see what the okay, it requires a high signature. Low, high, size is shape. Okay. Size 6. Oh, let's see here. Int 6. Symbol where? parse and expect a symbol here. Okay. Yeah, but this is for that. Okay, the signature required is by random randint. Low, high. So how can I give it size? Right. Shape. This expression wants to have shape. Okay. So that type shape here has a list. Okay. All right. Let's see. IP dot shape. Field constructor. I'm feeling like we already ran into this shape thing before. Shaped dot dimensions. P array. 1, 4. Let's see, 6 by 1. 1. Let's see, NumSharp. GitHub. Let's go to GitHub. I'm interested in seeing what the shape is. Splash size sharp, NumSharp. I hope this is right. Yep, that's it. Okay, so now what we want to do is we want to search for shape because I'm not sure what that shape is supposed to look like. So let's search for shape in this repository. New shape 4x3. Okay. So what you're telling me, I think, is you're trying to tell me shape. Oh, okay. I like that. I like that. I like that. All right. Interesting. Interesting. Okay. Okie doke. All right, we can proceed. So I guess we needed to instantiate a new shape here, which is fine. It's a little bit more verbose than our original code here. All right, but I guess it expects to be explicit here. They want us to be explicit. Okay, so let's try this again now. Okay, and we got to title let A2. And we stick size equals shape. Okay. And then A3, we want the same thing here, right? It's going to be a 3D. 3D. This one's going to be a 2D. And here we want to give it shape. Okay. Boom. Beautiful. Oh, not really. Got to call let here. What's the difference? Binding. Expect incomplete structure construct before it's going to let a is equal to MP random int. Valid numerical literals include. Okay. Okay. What's invalid about this? 3 by 4 by 5. Does it not support 3D arrays? So is it okay with this? Unexpected, symbolic. Let's take a look at shape again. Yeah, it should be able to handle. So expecting no. All right, let's try something. Well, no, that wouldn't matter either. Let's see, part errors are not valid, numeric literal. Oh, silly me. There we go. Yes, okay. You want an N64. Okay. Yep, silly mistake. It doesn't like comments like that. Int 64. You want an int 64. And then boom. Okay. Perfect. All right. Now that we are here, let's print a few things out. np, let's see, np print fn percent. Okay, so what I could do is this. I'm gonna do A1, A2, A3 list dot iter fun x. Okay, so what do we want to print out? Print fn percent. I don't know. I'm just gonna go do that because I have no idea what it's gonna look like. A3 dot n dim. Okay. It's gonna be x shape print fn percent a x dot size print fn percent a x dot d type. Okay. All right, so we want to get the dimensions, the shape, the size, and the d type for this, and we're gonna get it for all of them. Okay, and there it is. Right, so for A1, it's 1. Here's our shape. Here's our size. And the D type in 32. We do or get the same thing for A2 and then A3. Right? Wonderful. Okay. Explore the D type in other arrays. What types do you predict them to have? Okay, so indexing is pretty. Indexing stands for so A1. Okay, so if you want to index, all right, so arrays. Okay, so A1. Now, if we want to get A1 dot 0, then we get 8. If we get A1.4, we should get 5 back, right? A1.4. This is no different than what we would do with our traditional lists and arrays in F#. So this is very familiar. Now, if we want to get from the back, though, what we can do is 1 dot. If we do -1, and to use negatives here or to go from the back, we use the caret here. And in this one, I suspect we're going to get 5. Get reverse index. Now maybe you get strice, get tensor. Interesting. Okay. So you shouldn't be able to do this with F sharp. So for example, let's say let A T is equal to 1, 2, 3, right? And if we want to say T dot -1, yeah, see, the input must be non-negative. All right, so if I do something like T dot 0, I get a number. Okay, interesting. Okay, so it looks like NumSharp, like in Python, allows us to have these negative indices. And as we can see, the first one, in this case, we're going from the back. Our first one is 9 here. Okay. Interesting. Okay. And then if we do A1 dot -2, I suspect we get 5. Yep, there it is. All right. So multi-dimensional operator work like Python, list, and list. Let's try a few combinations. A2, okay. So for multi-dimensionals, let's try this one, right? A2. There's all this stuff. Now A2 dot 0 dot 0. Is that how you would index? Yeah. And we get 0, 0, which is our first one here. Okay. Now, if we were to look at it like 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2. So if we're doing 2, 0, it would be this one here. I expect to see 0. There we go. Okay, and then we can do negative indices as well. So A2 dot 2 dot -1. And in this case, we're looking at 2 negative. So 2 we're here, -1 we're here. So I expect to see 6. Nice. Okay. Okay, you can modify values. So A2 dot 0 dot 0. And if we want to modify that to 12, so 0, 0 is 4, and we want to modify that to 12. Let's see. Shown below. Type check error possible. Overload. The type is not compatible. NT array boolean. Interesting. Type constraint mismatch. Int. So I might not be able to modify this. Interesting. Okay. I'll leave this as is for now, and I'll try to figure it out later. Okay. Okay, slicing arrays. Okay, 1-dimensional, 2-dimensional. All right, let's just see what we can do here. Let's see. Slicing arrays. Right, so let's do it with way 1, 5. Expected symbol. Let's see. Expected symbol. Dot dot an expression. Dot. Remember, get slices not defined. Maybe you want to get the following. Let's see. How do they slice here? NumSharp. Let's go ahead and do a little search here. Slice. No, it's not slice. 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 There we go. Slice test. Okay. All right, let's try it. New slice. Five. Oh, okay. Well, this is weird. Okay. So I guess it expects a string. As opposed to in NumPy. Different to NumPy. NumSharp expects slicing done via strings. And parsed, and the appropriate slice is returned. Okay, this is weird, but okay. I can see how it works. So whoops. This case here, this one has to do a dot 5. And this property is given at least one argument. Oh, a1. There we go. Okay. A1 okay. 875. It's every other element 855. 855. Okay. It's cool. Okay. All elements reversed. So let's do a 1 dot, and then it's gonna be boom boom -1. Yeah, and you reverse them all. Interesting. Okay. All right. All right. Let's see this one here. Multi-dimensional slices. All right. So we got A2. All right. 2 rows and 3 columns. Okay. Let's try this. A2 dot. And we want to do 2, comma 3. So this was a 3 by 4. 1, 2, 3. 1, 2, 3. So there's going to be 3 columns, 2 rows, 3 columns. All rows, every other column. Okay, let me see all rows, every other column. Okay, we can reverse it. Alright, so it's going to be -1. Okay. -1 and -1. Okay. Cool. Very interesting. All right. Let's see. Accessing array rows and columns. Let's see. Important to know that if you use an array of no copies, there's huge difference between NumPy array and it's not Python list. Slices are only shallow copies of list. Copy doesn't affect the parent list. Modify NumPy subarray, you modify the original. Just be careful, this can have ramifications when you're trying to work with small part and large data set. You don't want to change the whole thing. Let's look more closely. Okay, now modify subarray. Okay, copying arrays. Reshaping arrays. Okay, so let's try this reshape thing. Okay, so grid is equal to on.reshape 3 by 3. Whoa. Alright, let's try this. Reshape in 32 dimensions. How much the size of given store size? Oh, 6. Okay. Yeah, okay. Fine. So let's go with let A4 4 is equal to np dot a range 1 comma 10. Okay. Fine. All right. So let's try that. And let me actually do A4 dot shape dot size. Shape. Yeah, so it's 9, right? Now I want to turn this into a 9 by 9, or sorry, a 3 by 3. And if I do grid dot shape, okay, what happens? Storage size. Shape size 9, which is not much given. Storage size 6. Oh, of course, because there we go. Now it's a 3 by 3. Okay. Nice. Another common implementation with data science, converting one-dimensional into two-dimensional row. Column entries is becoming necessary when doing linear algebra. For machine learning, why you can do this means reshape method. An easier way to use is a new axis. Okay, so fine. So what happens here? Let A5 is equal to np.array, and then this would be 1, 2, 3. Okay. Now I do A5. Okay. Now if I do a.reshape row vector via reshape 1, 3. Okay. And as far as error, yes, because I needed this. Just remember, reshape is not the A5. Okay. Doesn't seem any different, but okay. A New axis. New axis. Comma this. Let's see, np.newAxis. Okay, so you can do that. Column vector phi dot reshape 3 1. It's gonna look the same. It's just it depends that. All right, I think good enough. I'll figure out the new axis thing later. Now let's check out joining arrays. So let a is equal to np dot array, and then what we want here is going to be something like 1 2 3. Right. We want to do the same thing here. So 1 3 2 1, and I want this one to be b. Okay, let a and b, and we can join. Oh, let me actually joining and splitting arrays. Okay. All right. Right. So if we want to join them, we can call concatenate a b. Okay. It was expecting it in the array. Okay, of course you are. Boom. Okay. Now we have 1 2 3 3 2 1. Perfect. Can also be used on this. So this my grid look like 1 2 3 4. Okay. Grid dot shape. Okay, it's a 3 by 3. So, all right. So let's imagine this, right? np dot concatenate grid. Okay, nice. To the array joining, and then if I were to, I don't know, let's see, is equal to, and if I were to do something like c dot shape, I should get a, well, it'll be a 3-dimensional now. Oh no, it's a 6 by 3. So before it was a 3 by 3. Grid dot shape. Right, it was a 3 by 3. Now it's a 6 by 3. Okay. And concatenation along the first axis. Yes. Yes. More rows. Splitting arrays. Arrays. All right. So np.split. So in this case, it's gonna be let a is equal to 1 2 3 9 9 9 9 3 2 1. Okay. And what I want to do is I want to do a 1-dimensional array. So I want to do let a1, a2, a3 go to np dot split a 3 by 5. Dot split is not defined. np dot split. let's see here. Okay. Let me see. What is this? P dot split. Huh. Let's see. So it appears that NumSharp doesn't have the split method. Let's see. Split. Yeah, this is string, but I wanna. Okay. Let's see. Split. Empty array implicit operator. There doesn't seem to be a splitter. Interesting. Okay, so that's gonna be interesting. Okay, so there is. So let's go to github.com/sharp NumSharp. Okay. Let me ask a question. Issues. All right, let's see if there's anything around split here. Closed. Show winner shall implement one interface or implement methods and extended methods. I don't see anything around this. C#, F#. Let's see if sharp can't invoke extension methods. I don't have to look at a different file. Are you sure if sharp can invoke methods? So you're not 100% currency state, but remember. Okay, let's see. Let's raise an issue. Oh, I have to log in. All right, no worries. Let's see here. Go to github.com. Let's see here. Trying to do here. Okay, so we want to go to C# here. I want to raise an issue. Okay. New issue. Split. ND array split. When trying to split an ND array, I get the following error. Okay. And what is the error that we get? Okay. The field constructor is not defined. Okay. I should probably tweak this a bit. Okay. Given the following Python code, Python. Okay. Translated to the following in F#. Following F#. sharp. Sharp. Okay, now what does it look like for us here? It looks here. Okay. Okay. So split the array, get the following error. Split. Calling split on its own, also without any parameters. It also any input arguments also returns the same error is split implemented in NumSharp. Okay, so let me just preview. Given the following Python code, translate to F#, just call split. I get the following error. Can't split. Okay, cool. I like this. Submit it. All right, so we'll see. I don't know if ND array is, or sorry, if NP split is part of this. So we'll figure this out. Hopefully this team, they're usually pretty responsive, but again, they do a lot of this on their own time. So yeah, in the meantime, I think that this is a really good stopping point for us. We're going to go ahead and call it a day for now. And what we're going to do is next time on Wednesday, I am going to continue talking about Stamina, which is the doing or using deep learning for static malware analysis. We got to a really good spot last time where now we're able to process multiple files. So what we're going to do on Wednesday is we're going to instantiate a VM, right? Because it's the data set that I want to use has a lot of data, and I don't want to put all of that data into my local PC. It will take forever. So what we're going to do is we're going to spin up a VM in Azure, and we're going to download the data there, and then we're going to use the script that we've written thus far to try to pre-process the data and turn the files that are included in the data set that I'm trying to use into images, which we're then going to use as training data for our deep learning to build our deep learning model that's going to categorize the different families of malware that's out there. Okay. Till then, feel free to just keep playing with this. If you've sort of set up your own, if you forked your own version of these reactors, you are more than welcome to fork my version, right, and continue working off of this. And mine is under the Stream Projects Reactor Workshops. And yeah, till then, I'll see you Wednesday. Take care. Bye.